Hello everyone, I am Dr. Kanchan Wagh from Cummins College of Engineering for Women. Today I would like to talk on orbital perturbations. The contents of my presentation are oblateness, orbital perturbations and longitudinal changes. Coming towards the oblateness, it is the measure of how much a rotating object deviates from being a perfect sphere. A perfect sphere has oblateness of 0.0 or 0%. The Earth oblate to a factor of 0.0034, it means 0.34%. The equatorial diameter of the Earth is greater than the polar. The Earth is compressed along or flattened at the poles. Coming towards the orbital perturbations, a satellite can be influenced by many factors such as gravitational fields of Sun, Moon and lunar eclipses, solar radiation pressure, asymmetric gravitational field due to Earth's oblateness. These interfering forces cause the true orbit to be different from a Keplerian ellipsis. This may cause sub-satellite point to move with time. Due to perturbations, the satellite does not return to the same point in the space after each revolution. The elapsed time between successive perigee passages is called anomalistic period. Result of this is the orbit no longer a perfect Keplerian ellipse. Switch over to the longitudinal changes. The Earth neither a sphere neither a perfect sphere nor a perfect ellipse. The Earth is flattened at the poles. The equatorial diameter is about 20 km more than polar diameter. These are the regions where the average density of Earth appear to be higher. These are called as region of mass concentration or mascons. The non-sphericity of the Earth, the non-circularity of the equatorial radius and the mascons leads to a non-uniform gravitational field around the Earth. Because of this force, the orbiting satellite will vary with position. Due to position of the mascons and equatorial bulges, there are 4 equilibrium points in the geostationary orbit. 2 of them are stable and 2 are unstable. The stable points analogous to the bottom of a valley and unstable points are analogous to a top of a hill. If a ball is perched on the top of a hill, a small push will cause it to roll down the slope into a valley, where it will roll backward and forward until it gradually comes to a final stop at lowest point. The satellite at an unstable orbit location is at the top of a gravity hill. Given a small force, it will drift down the gravity slope into a gravity valley and finally stay there in the stable position. The stable points are at about 75 degree east and 252 degree east, and unstable points are around 162 degree east and 348 degree east. If a satellite is perturbed slightly from one of the stable points, it will tend to drift back to the stable point without any thruster firings required. A satellite that is perturbed slightly from one of the stable point will drift toward the nearest stable point, oscillate in longitudinal position about this point until it stabilizes at that point. These stable points are called as the graveyard geosynchronous orbit locations. Thank you.